Okay, now you're going to apply the roots and exponents to some real life problems. They're not hard to do. In the table showing the lengths of the sides of a square are given, find the areas of the squares to the nearest decimal places. So here, a equals s to the second. Okay, you shouldn't really need that formula, but it's there. A is the area, that's the inside part, and s are the sides. Because the area of the square is the s times s, hence s to the second power, because it's s times s. So again, that's why they're giving you the formula. You shouldn't need it, but they gave it to you. Now, on this first table, they give you the length of the sides. If it just says feet, that's the length of a side. When you get to area, you want it as square feet, which means feet to the second. Well, then you just take your 1.25 to the second. 1.5625. 2 decimal places, so 1.56. That's a length. When we want the area, we want it to the second power. Okay, it's cm to the second. So I have to take how many centimeters I have to the second. Okay, so 0.325 to the second, 0.11. Okay, yards is a side length. The area is your square yards. So since the sides are the same, you simply can square that. You're taking 2.35 times itself. 5.5, and also if it's a second power, you can just click that key right there. So 5.52. Okay, km, when you're getting to area, you want km squared, so you raise it to the third power. 0.29. Same thing here, it's just repetitive then after you get that. No, I did it to the third power, that was stupid. Okay. Be third power if we were doing volume. Okay, 0.44. 44. Okay, so I want square feet when I'm looking for area. Okay, so we raise our the side length to the second power since the sides are the same. 0.01. Okay, that one's pretty easy. You gotta pay attention to what you're finding. Alright, now it's a three-dimensional object. Here's why the volume is s to the third, because volume is length times width times height, but they're all the same. They're all s's. S times s times s. It's s to the third power. That's why that is. So they're again giving me the side length. I have to find the volume. Okay? Volume is raised to the third power. Don't put it on the label. Come over here. You want to take mm to the third power. Well, that means I'm going to be raising my side length to the third power. 9.705 caret 3, 914.09. Okay, inches is a side length. Now when I want volume, I want cubic inches. So I raise and it's a perfect cube, SSS, okay? Now if they were all different dimensions, what I'm doing would not work, but they will be, okay? Okay, 57.51. Volume is length times width times height, but when all the sides are the same, it's S to the third. Okay, feet to the third, cubic feet. Now raise your 6.6 to the third. 287.50. Okay, next one, cm. When I want volume, I want cm to the third. Okay, so I need to cube my side length because it's a perfect cube. 1.24 feet to feet cubed. Well, that means I just cube what the side length is. 0.88 to the third. 0.68. Yes, it's possible for the volume to be less than the side length. Okay, it is. Especially when your side length is less than one whole. That's the only time it really happens, but it can happen. Okay, number 3. Now you're going back the other way. By the way, I don't like this SQ feet that these clowns put here, okay? Cross out SQ and put second. You're going to have to do that on the assignment. That's what square means, to the second power. All right, now they give you the area. You got to get back to the side length. So now I want just feet. Here I want just km. Here I want inches. Here I want meters. Here I just want feet. They give me the area. I want to find the side length. Well, to get that, so I want to unsquare the number. Well, that's the square root, okay? So the square root of 125. So second, key next to the 7, 125. 11.18. Okay, now we want to go from the square back to km, so I do the opposite, which is square root. So second square root, 8.76, 2.96. It's like I always told people in algebra, okay? Opposite of a second power is a square root. That's essentially what we're doing. The opposite of a square root is a second power. So the square root of 57.75. 7.60. Square root 0.88. 0.94. Square root 2479. Okay, 49.79. You got to pay attention. They give you the square feet. You want to get back to just the feet. Okay, then on number 4, they give us the volume. They give us the cubic. Cubic means to the third. To the third. Square means to the second. Cubic's to the third. Because it's 3-dimensional. Now, just like on the last problem, you're trying to get it from cubic cm to the third power just back to cm. On the next one, just to feet. The next one, just to meters. The next one, next to just to yards, and then feet. Well, I'm going to apply a root, but it's going to be a cubed root, okay? So I go 3 second caret 18.60. You can't go 3 second and then next to the 7. It's got to be 3. When it's not a square root, you got to go 3 second caret, okay? 2.65. And then I just repeat the same process, okay? So what to the third power is 143.77? Well, you don't actually know, so that's why you use the cube root function. 3 second caret, hit the wrong button, okay? You can't do this, okay? If you do this, it's going to be wrong, because that's doing 3 second square x squared. It's 3 second caret, okay? 143.77, okay? 5.24 is the side length. Okay, 3 second caret, 1.896, okay? 1.24. 3 second caret, 0.750, 0.91. 3 second caret, 953.25, okay, 9.84. All right, now, not a lot of thought really on that, okay. Next one's another table. Find the current in amperes of the circuits listed in the table. Express the answer to the nearest tenth. Now, I is the current in amperes. It is equal to the square root of P divided by R. P is the power in watts, R is the resistance. So the power on the first one's 120, the resistance is 3.45. First I need to simplify and divide, okay? I don't care how much work you show, but you got to do it correctly. 34.78, just always round to the nearest. And then I need to find the square root. So second, x squared, 34.78. 5.90 is the current, okay? The label on that is amperes. Just put AMP, okay? Next one, then it's essentially just repeating the same process, okay? So the next one, I equals the square root. We're going to first divide 1400 by 1.23 before I do the square root. Okay, 1138.21. And then apply the square root. So second square root, 1138.21. 33.74 AMP. Okay, next one, I equals 1600 divided by 4.33. Okay, 369.52. And then I apply the square root. Okay, 19.22 AMP. And last but not least, I think you know the drill by now. We're going to divide 8,999 by 20.55. Okay, 437.91. And I find the square root of 437.91. Okay, 20.93. Okay, number 6. Before we start this problem, we are going to use some unit ratios, okay? And you can do it another way if you want, okay? I will explain another way. Dollars and cubic meter, okay? Now, in lining your rate up, I want dollars. Don't put cubic meter. Put M, meter to the third power. That's what cubic means. So that means $6.25 for 1 cubic meter. Now, we got to find the cost, okay? I didn't read the problem. Compute the cost of filling a hole 4 meters long, 4 meters wide, 4 meters deep. The cost of fill soil is $6.25 per cubic meter. Round the answer to the nearest dollar, okay? I have to compute the cost, so that's what I don't know. So I better be able to put something in for cubic meter. Now these are all meters. To get it to a cubic meter, you simply take 4 to the third power, or 4 times 4 times 4. 64, okay? So 64. So I take $6.64 times $6.25, divide by 1. Really, you're just timesing it by that. $400. Okay, a quicker way without the ratios, you know you're taking that times how many cubic meters you have. So 625 times whatever 4 times 4 times 4 is. Okay. Okay, number 7. A paving contractor, in determining the cost of a job, finds a number of square feet area to be paved. The shaded area that surrounds a building is paved. All dimensions are in feet. At 75 cents per square foot, determine the cost of the job. So we got dollars and square feet. That's the rates here. Dollars, and please put feet to the second. Make sure you put your second tiny so you don't think that's a 2 here. So that means 0.75 for 1 square feet. So dollars and square feet. Well, here's the deal. I'm finding the cost, but I really need to do some work to find my square feet. So I'm going to put feet to the second, and we're going to talk about this. To find the square feet that need to be paved, we're going to take the entire, the square feet in the entire square, and I'm going to subtract the square feet in the building, okay? Because we don't pave around the building. Well, this is easy, okay? The entire square is 140.5 by 140.5. So take your 140.5 and raise it to the second power, okay? Minus building. Well, the building's 50.5 by 50.5. So 50.5 raised to the second. Now, I can punch that all in my calculator. 140.5 to the second minus 50.5 to the second. Because again, you want square feet, so you need to square those numbers. Take them to the second power. 17,190. And that's how many square feet you have. Now you can cross multiply and divide. So 0.75 times 17,190, okay, divided by 1. So $12,892.50. There's your answer. Now, a quick way you could do that is take your 75 cents times, but it says per square foot, so you need to first make a parentheses, because you're not going to, and you would take it times 140.5 to the second, because that times that is a square feet inside the whole thing. But then the parentheses is there because I have to subtract the square feet in the building, which is 50.5 to the second. Okay, same thing. Okay, number 7 is just a plug-in problem. Keys and keyways have wide applications with shafts and gears. The relationship between shaft diameters and key sizes is shown by the following formula. The formula is it makes it an easy problem. What's the shaft diameter that would be used with a key where L equals 3.5 inches and T equals 0.5 inches? Okay, so D equals, so L, that's the key length, that's 3.5 inches, times T is the key thickness, 0.5. First we need to find what we're finding the square root of. Okay, first I need to multiply, then I'm going to divide that answer by the 0.30. Okay, 5.83. And we need to apply the square root to that. So the square root of 5.83 is 2.41. Okay, diameter would be in inches. If you don't know what the label is, ask me. Okay. This would be dollars. Okay, number 9 is the toughest one, I would say. Okay. A plot of land consists of two parcels, A and B. Both parcels are squares. Okay, that's important that they're both squares. The plot has a total area of 10,625 square meters. Find in meters the length of C. So I have to find how long C is. I know one of the parts of C pretty easily. This is a square, so 100. 100. So I know this part of the C is 100. Plus, now I need to find the other part of the C, and I'll have my answer. Okay. Now let's talk about this. So we want to find how long the side of the little. Once I know how long one side of the little square is, I can just add it to 100 and have my answer. Now the plot has a total area of 10,625 square meters. So right here, you're not going to be able to see it on the camera, but 10,625 m squared. Okay. Now what we are going to do to find first is we are going to find the total area. We're going to take the total area of the whole thing, which we know is 10,625. We're going to subtract the area of B. And that is going to equal the area of A. So the total area I know is 10,625. Okay. M to the second. Minus B. Well, it's not hard to find what B is, the number of meters squared. See, these are just meters, the 100s are, okay? So 100 to the second, okay? So you'd have to square your 100. You take your 100 to the second because you want that to go from 100 meters to what is it in meters per second. So I raise 100 to the second. Or 100 times 100, whatever. But that's going to give you the area of what's inside of B. Because we need to know the area of B. 10,000. I got 625 square meters, okay? But that's not this question mark, okay? It's square meters, so it's inside, okay? Now I want to get it into just meters, because all I'm doing is measuring a side length. Well, to get that to be just a side length of a square, we just apply the square root to 625, okay? So the square root of 625 is 25. 100 plus 25 is 125, okay? And that would be just meters. Okay, here's a quicker way you can find it. Okay, so you need to write 100 plus, because you know you have 100. Quicker way you can find it is this. Well, you can take your 10,625, okay? Your total area. That's your total. So to find how long the parcel A is across the bottom, okay, I'm going to need to first subtract out the area of the B parcel, okay? Now the area of the B parcel, I'd take 100 times 100, or 100 to the second, okay? That's what I got, okay? And then I apply the square root to that, okay? So again, yeah, that's kind of a confusing problem. So C plus, okay? So they give me the total area. I take the total area and then subtract the total area of B, okay? So the total area was 10,625. And then the area B you can find by taking 100 to the second power, or 100 times 100. That's how I got the 10,000. Then I subtract, I get 625. That's the area, though, of parcel A. To find the side length of parcel A, you apply the square root, okay? Okay, number 10 is an easy problem. A steel storage tank is to be fabricated by a welder. The tank is to be made in the shape of a cube capable of holding 2,000 gallons of water. 1 cubic foot contains 7.48 gallons. That's a rate, okay? Find the length of one side of the storage tank. I don't want to say it's easy, okay? You got to take some time here. So you're going to put gallons and cubic feet, but you write that as feet to the third power. Don't put cubic feet, okay? I want you to see a third power there. And 1 cubic foot is 7.48 gallons. And then I align the labels the same way. Well, I have 2,000 gallons, so I'm not finding the gallons. I need to find the length of one side. So first, I find the cubic feet, okay? So I take 1 times 2,000 divided by 7.48. Okay, 267.38. But that ain't your answer, okay? When they're asking you how long a side is, it can't be in cubic, okay? Just like that last problem, they're asking you how long a side is. That's why once I got the 625, I had to do the square root, okay? Again, they're asking me a side. So a side is just feet, okay? No exponent, feet. So how would I get that from a third power down to just feet? Well, I'd apply a cubic root. Okay, so 3 second caret 267.38, okay, 6.44. So again, ratios are great, but just remember, you're going to get cubed feet. And when you're trying to find how long one side is, you need to then apply a root, okay? Like on this problem right here, okay, after I got the 625, I take the area of the whole thing, area inside the whole thing, minus the area from parcel B, which is 100 to the second, 100 times 100. I got 625, but a side length wouldn't be meters squared, it's just meters, okay? So after I get the meters squared inside, I have to apply the square root. Okay, number 11. Find the total cost of carpet and installation for the office floor plan shown. The carpet is priced at $27.50 per square yard. Okay, so money in square yards is what we have here. Put yards to the second. Okay. A waste allowance of 3.5 square yards is made, and the installation cost is $3.50 per square yard. Find the total cost. Now, you have two costs per square yards, okay? Both of these. So you can put 1 square yard, and you're going to add the $27.50 to the $3.50, and that's going to be $31, because that's the rate. Okay, now I got to find the total cost, so question mark. Now, we want yards squared. Well, let's look at this. These are side lengths, okay? So those are not yards squared. Those are just yards. You can see that right there. Yard, yard, okay? To find the square yards, I just take 5.4 to the second power. Okay, 29.16. Now I cross multiply and divide, and I have it, because that's how many square yards I actually have, okay? These are just regular yards. You have to take one of those sides to the second power to give you your square yards. 903.96. Okay, cost. And the last one's just a plug and chug. The plate shown is designed to contain 100 square centimeters of metal after the circular cutout's removed. A designer finds the length of the radius of the cutout to determine the size of the circle to be removed. Find in centimeters, so the length of the required radius to 2 decimal places. So radius equals. Now your A, area of the circle, okay? Wait a second, did I give you enough information in this problem here? Yeah, I think I did. So you know you got 3.1416, okay? Then we have to find the area of the circle, okay? Well, here's how this is going to be done. Okay, you have to do a little bit more work here than I originally thought, sorry, okay? Area of the circle, circle area. You need to do a subtraction, okay? You're going to find the area of the whole thing, okay? So area inside the whole thing, I take the 12.3 to the second power, because their sides are the same. 12.3 times 12.3. And then the circular, you're going to cut out the circular part. Well, it tells you up here that's 100, okay? So I'm going to take 12.3 to the second power minus 100. And that's 51.29. Or no, that's what you're going to put, 51.29, okay? I didn't explain that very well at all. God, terrible explanation, okay? So you have to find the area of the whole shape, 12.3 to the second. And it said the plate shown is designed to contain 100 square centimeters of metal after the circular cutout is removed, okay? So after we cut out that circle, the shaded part's going to have 100. So to find the circle, you're still going to subtract, okay? So again, you have to find the area of the entire thing, okay, by raising that to the second power. And then you're taking out the circle, but it tells you that you're taking out the circle, okay? You don't know the circle, but you know at the end there's going to be 100. So you subtract the difference is your 51.29. It's not that I did anything wrong, I just explained it idiotically, okay? So 51.29 divided by 3.1416, 16.33. So I find the square root of 16.33. That's going to be 4.04. That's your radius. So again, because I did such a bad job, let me talk about it. So you know you got to put something in for area of the circle, but they don't really give you that information. You have to figure it out, okay? So you can find the area of the whole thing. 12.3 to the second power finds the area inside the whole thing. Then you're going to pop that circle out. You don't know how much the circle was, but after the circle's out, it's down to 100 square centimeters. So I just find the difference in 12.3 to the second. That's the area you start with, okay? Then after you cut out the circle, you have 100 left, okay? So what was a circle? Well, minus 100 is that, 51.29, then I plug it in.